Today we're diving deep into one of Earth's most spectacular and, let's be honest, slightly terrifying wonders, the Yellowstone Supervolcano. You've probably seen the headlines, "Supervolcano ready to blow." Is this the end? But what's the real story? Is Yellowstone a ticking time bomb, or is there more to it? Let's break it down. First off, what even is a supervolcano? Imagine a regular volcano, like the kind that forms a classic cone shape. Now scale that up, way, way up. A supervolcano doesn't usually look like a mountain. Instead, it's a massive underground chamber of magma, a reservoir of molten rock that can be dozens of miles across. When it erupts, it doesn't just ooze lava. It explodes with a force hundreds of times greater than a regular volcano, creating a giant collapsed crater called a caldera. Yellowstone is one of the world's most famous calderas. The park sits on top of a hotspot, which is basically a giant plume of superhot material rising from deep within the Earth's mantle. Think of it like a giant blowtorch aimed at the underside of the Earth's crust. As the North American tectonic plate slowly drifts over this stationary hotspot, the plume has punched through the crust multiple times over millions of years, leaving a trail of ancient calderas across states like Idaho and Oregon. Yellowstone is just the current location of the action. Over the past 2.1 million years, the Yellowstone hotspot has produced three truly massive super-eruptions. The first one, 2.1 million years ago, was colossal. It created a caldera so big that the current Yellowstone Park almost fits inside it. The second was a bit smaller, about 1.3 million years ago, and the most recent one, about 631,000 years ago, formed the caldera we see today. If you do the math, you might notice a rough pattern of about 600,000 to 700,000 years between these super-eruptions. Since the last one was 631,000 years ago, well, you can see why people get a little nervous. So, are we due for another big one? This is where the science gets really interesting and, thankfully, a lot less alarming. The idea of being due is a bit of a misconception. Volcanoes don't operate on a strict schedule like a train. The intervals are just averages, not deadlines. The most important factor isn't time, but what's actually happening underground right now. And for a super-eruption to happen, you need a critical ingredient, a huge amount of eruptible magma. Think of the magma chamber like a soda bottle. To get a big explosion, the bottle needs to be full of liquid and highly pressurized with gas. If it's only half full or not very fizzy, you won't get much of a pop when you open it. Scientists use cutting-edge technology, especially seismic imaging, to get a picture of what Yellowstone's magma chamber looks like. It's like giving the Earth a CAT scan. They send sound waves deep into the ground and measure how they bounce back to create a 3D model of what's down there. And here's the surprising part. Recent studies have shown that the giant magma reservoir beneath Yellowstone isn't a big, sloshing pool of molten rock ready to erupt. Instead, it's more like a crystal mush. Imagine a giant snow cone, but instead of ice, it's mostly solid crystals with a bit of liquid magma filling the spaces in between. For the upper magma chamber, estimates suggest it might be as little as 5 to 15% molten. That's not nearly enough liquid magma to fuel a super-eruption. It's essentially too solid to blow. The system is still hot, absolutely, but it's not in an eruptible state. This leads to the idea of the broken supervolcano. Some geologists have proposed that after its last major eruption, the Yellowstone system may have fundamentally changed. The processes that allowed such a massive amount of magma to accumulate in the past might not be as efficient today. The plumbing system might be fractured or solidified in a way that prevents it from fully reloading. It's like the soda bottle now has a slow leak, so it can't build up the same incredible pressure it once did. But hold on, that doesn't mean Yellowstone is completely dormant. Not by a long shot. It is one of the most geologically active places on the planet. We see this with the thousands of small earthquakes that happen every year. The ground in Yellowstone is constantly rising and falling as magma, water, and gas move around beneath the surface. And of course, there are the geysers and hot springs. Old Faithful is a direct consequence of this underground heat. Water seeps down, gets superheated by the magma system, and then erupts spectacularly. So if a super-eruption is off the table, what is the actual threat? The most likely and far more common type of eruption at Yellowstone is a hydrothermal explosion. This happens when underground water is flashed into steam by the intense heat, creating a powerful explosion that can hurl rocks and create craters several hundred feet across. These are localized events and happen every few thousand years. They're dangerous if you're standing right there, but they won't affect the global climate. The next step up is a lava flow. The last one of these happened about 70,000 years ago. These are slow-moving flows of thick, rhyolitic lava that would be destructive within the park but wouldn't explode violently. They'd be a major geologic event, but again, not a global catastrophe. So while the big one gets all the attention, these smaller, more frequent events are the more realistic hazards. The Yellowstone Volcano Observatory, a partnership of scientists from the U.S. Geological Survey and various universities, monitors the area 24/7. They have a dense network of seismometers to detect earthquakes, GPS stations to track ground movement to the millimeter, and instruments to monitor gas emissions and temperature changes. If anything were to change, if the magma chamber started to show signs of becoming more liquid, or if the ground began to swell rapidly, we would have warning. The consensus is that we would likely have weeks, months, or even years of clear signals before any major eruption. It wouldn't be a complete surprise. To put it all in perspective, the annual probability of a super-eruption at Yellowstone is about 1 in 730,000. To give you some context, your odds of being struck by lightning in your lifetime are far, far higher. Geologists are much more concerned about other, more active volcanoes around the world. So is Yellowstone a threat? Yes, but not in the way the disaster movies portray. The real magic of Yellowstone isn't the threat of a future catastrophe, but the living, breathing evidence of the immense power shaping our planet right beneath our feet. The system isn't dead, but it's not primed to explode either. It's a complex, fascinating, and relatively stable geologic wonder. The geysers, the hot springs, the earthquakes, they're not signs of an impending doom, but rather the heartbeat of a truly dynamic and awe-inspiring place. Next time you see a scary headline, remember the crystal mush. Remember the incredible science and monitoring that helps us understand these forces. And remember that the most likely eruption you will see at Yellowstone is the spectacular display of Old Faithful. Thanks so much for watching. If you found this deep dive interesting, give this video a thumbs up. And don't forget to subscribe and hit that notification bell so you don't miss our next adventure into the wonders of our world. Let me know in the comments what other massive science topics you'd like us to break down. See you next time.